Good morning, everyone. So today we are going to talk about complexity over time and how complexity plus time equals tragedy. So let's get into it. Now, this one is going to require a little bit of context. So let's have a brief history lesson. The history of how I realized how wrong I have been about trendy software design, and the reason why, well, basically how I realized that there is a subtle benefit to design. There are downsides, of course, but the subtle benefit of how traditional software application design, as taught to me by my teachers in the university, actually has another layer to it that I didn't actually think about when I was judging it, because I was judging it. So let's talk about it for a moment. Now, it used to be the case that I, just as you could have probably expected, started learning traditional software design. And as most youngsters who get into software development, you start out by just learning the concepts and getting to that point where you kind of feel that you realize that, all right, this is the way this works and this is the intention behind it. And you get your bearings basically when it comes to software architecture and the reason behind different architectures. One example of an architecture could have been something along the lines of MVC, Model View Controller. That's a very standard way of building an application. And when you start learning these concepts, you start out as you expect. You kind of just learn how it works. You don't reflect so much necessarily why it works the way it works, but you start out that way. And when this thing that you've learned become old hat, basically, and you feel that, yeah, I kind of know how this works. You've been doing it a few times. You put up a few projects and you know how the structure should work. You get to be a little bit of a philosopher because you feel comfortable in your skills and you feel like, yeah, I kind of know this. And you start looking around at these bloggers and other people who kind of give you a different perspective, and they are probably sometimes they're in the same mindset that you are, and sometimes they are even more experienced. They just forget to maybe define a few things. And that's hopefully what I can define for you now in this little video of mine. But anywho, you start getting different perspectives on traditional software development, and you get it into your head that, hey, this could be better. And you listen to the idealists out there in the world who talk about best practices, and they talk about improving traditional architectures and trying out new approaches to doing things, and you start doing that, and you start convincing yourself that this new way of working is so much better than the old way. And so you start working and you start creating projects which, for some reason, yes, in a way, they don't have the same type of limitations as you perceived the old way of working has, but they have other problems instead. So you kind of slightly trade one set of problems for another set of problems. And to give you a more concrete example, you may not know this, but there's a very standard, very traditional practice in Java development, which is called a service-oriented or a service layer type of architecture to the MVC pattern. So basically the idea is that you have a model, a view, and a controller as in any MVC pattern, but the difference is that in order to kind of mitigate some of the complexity that comes with having a controller layer, because what usually happens is that if you don't have a layer between the controller and all your business logic needs to go into the controller, which means that the controller gets to be this code hub where absolutely everything that needs to happen when somebody hits an endpoint is going to execute. That gets complicated and very, very unmaintainable very quickly. It becomes all virtually untestable as well, at least from a unit testing perspective. So the idea came about to have services, which is basically the idea that you have a service such as a user service, a product service. You can even have more complicated services like an email service or a purchasing service, so forth. And basically all the services is just a POJO, or a regular object, which has a bunch of methods that executes all of the business logic. That was the idea. So what's the difference between this and just a regular object or an instance of an object? Why do we call it a service? Well, a service indicates that, or rather, a service is usually the sort of thing that has a lot of complicated logic. Usually the single responsibility principle is very true in a lot of ways. It's the idea is that a good method or a good function it does a single thing, and it does only that one thing, and that's it. But a service is by necessity doing more. Most of the time it's doing more than one thing, and it does so because usually this perfect way of thinking that a method only does one thing and it does that one thing, well, that works when you get further down into the application. But at the very top, when you want more than one thing to happen, so let's say that you wanted to buy a product on your system, and then apart from that you need to log to create a record, you need to update the user model, the products need to be fetched from there's tons of stuff that could be happening, and there's all subtle things as well. Maybe you want some event tracking to go to one of your system to know that how many people are buying products on your system. There's tons of other things that could kind of happen around that core concept of somebody wanting to buy a product on your system. That's where the service comes in. So you basically bundle all of this complexity and all these different things in a service instead of putting it in the controller. And as I said, the benefit of this is that it's a little bit more portable. It makes the controller a little bit easier to maintain. So I questioned this quite a bit for a long time, because the limitation of having something like this means that the service method may depend on a lot of complicated business logic and other objects, and a service can depend on other services as well. So when you want to test that becomes really tricky very quickly, because you have to stub and mock and fake, and there's so much stuff that can go on in this service, and it becomes a little bit of a problem to maintain, or a slight problem. So people have had other ideas how to approach this problem that are much more elegant from an engineering perspective. You have pure functions, you have event-driven systems where you dispatch a message, and there's all kinds of handlers that do one part of their thing, and so forth. And what I've worked with a lot of these different approaches to solving this fundamental problem. And the other day, I was walking through the code, because we have a very similar architecture in my company. And I was walking through all the different services, and I was looking at the different commits from different people who've been working at the company for many years. And there have been people who are not working at the company anymore committing code, and there are people working there today that are committing code. And I just had this realization, because when I was looking at this defined architecture of service, I saw the limitations of the service approach. And then I looked at those pieces of code, because you always have those pieces of code in a large code base. You always have somewhere where there's an exception to the rule. And when there is an exception to the rule, it falls into two categories. Either the exception is there because somebody found a very good reason to deviate from this established way of working, because there was some corner case that this very stable and proven way of writing software isn't going to be a good fit. And the other way is where I see the most things happening, basically, is where somebody thought that they had a better idea. They thought they were smarter than the pattern that is already established. And on average, when I just had this realization, I realized that the thing that happens is that although yes, if when you understand, when you really look at the solution and you really get down to it, it's a nicer engineering approach. It's a more elegant solution. It's not an elegant solution. That's a different thing. But it is a smarter, a more clever solution. But the problem with being clever is that I realized that these solutions, I was looking at several of them, these different differences in approaches that deviated from the standard, and I realized one thing. Each of these approaches was kind of different from every other approach. They kind of were working on a case-by-case basis, which meant that each solution couldn't uniform with anything. There was no pattern in the way of solving the problem. It basically became a situation where each solution was its own thing. Every person who had done it made their own implementation of how to solve the problem. And that's when I don't know, I felt like I reached enlightenment. I realized that this service-oriented way of working has the downside of having a lot of boilerplate testing code that is required in order for it to be testable, which is absolutely a downside. But the benefit is that it was a uniform way to solve almost every single standard problem that you have. So 90% of the time, it's a perfect solution. It's a very understandable, a very simple solution to scaling up a big project with a lot of complexity. It scales extremely well. It has its downsides, but it's simpler than that perfect engineering solution that worked for each specific case. And I started thinking, maybe that's the intention. Maybe this was never designed to actually be a perfect fit for every specific type of problem. Maybe it was designed to be this generic type of solution that works for almost every case and keeps down the complexity, because complexity over time is the biggest problem that you will face. That's at least what I have come to realize. Things become unmaintainable because they become complex. They very rarely become unmaintainable because a solution is too simple, or there's too much boilerplate, or anything like that. So maybe the intention of this architecture was not to be this perfect harmony of engineering masterpiece type of thing. Maybe it was just designed to be a streamlined way to consistently produce quality software. Think about it. Have a great day.